So yesterday we talked about finding the measure of an angle in standard position, but we dealt with problems where both of these numbers were essentially the same. Both coordinates were the same or similar. Anyway, maybe one was negative, one was positive, but basically they were the same absolute value of the number, which meant that we were dealing with 45-degree angle in that quadrant. Today we're going to look at a couple where these numbers are not the same. And we need to figure out what angle we're dealing with. Now, for now, we are basically going to deal with 30s, 45s, 60s, 90s, and multiples of those, okay? So these examples, this angle in here is either going to be a 30 or a 60. Okay. Now it looks like a 30. But how we are going to identify what that angle is going back to what we talked about in section 13.1 and dealing with, or no, it was 13.2, dealing with our special right triangles. So what I know, since this point is at -1/2, this distance right here is 1/2. And negative square root of 3/2 means that this distance right here is square root of 3/2. So in a 30, 60, 90 triangle, the side that is across from the 30 is the shortest side, right? Shorter leg. And the side across from the 60 is longer than, so which one is smaller, 1/2 or square root of 3/2? Which one is smaller? 1/2 or square root of 3/2? They're both over 2. Which one is smaller, 1 or square root of 3? 1 is smaller. Square root of 3 is larger. Because if this was square root of 1, it would be just 1. Anything bigger than that is going to give you a number larger than 1. So because 1/2 is smaller, we know that this has to be a 30, that has to be a 60. And when we deal with 30, 60, 90 triangles, the longer leg is always the square root of 3 times the shorter leg. So this angle right here is 30. So this angle right here is 60. And this is 90, and this is 90. So 90, 90, and 60 give us 240. So part B, you can draw in your right triangle. Either against the x-axis or the y-axis. So the fact that this is -1 tells me that my x value for this point is -1. So this piece right here is -1. And my y value is negative square root of 3, so this is square root of 3. And this is, yeah. We'll just say that distance is 1. And this distance is square root of 3. Again, we're basically only dealing with 35, or 45, 45, 90, where these two numbers would be the same, or 30, 60, 90s. So which one is smaller, 1 or square root of 3? 1 is smaller, which means, so this angle right here is 30. So this angle right here is 60. So again, we have 90, 90, and 60, which again gives us 240. Okay. So the unit circle really is just a circle centered at the origin with a radius of 1, which is why we call it the unit circle, because the radius is 1 unit. So each of the, where the circle intersects each of the axes is at 1. So we have the 0.10, 0.01, -10, and the 0.0, -1. So each point on the circle is related to periodic functions. We are going to introduce a sort of new variable. That variable is theta. Theta, it is a Greek letter. What? So we use the Greek letter theta typically as a variable for angle measure. So, you know, we use X and Y a lot on the coordinate plane. We get Z in there if we give it 3 dimensions. Theta is typically the variable that somebody chose at some point in math to use for angle measure. So we are going to deal with a lot of angle measures that we are going to call theta instead of some other letter. For any angle, or for each angle, theta. In standard position. So for each angle theta that we can draw in standard position on a coordinate plane, the x-coordinate of the point where the terminal side of the angle intersects the unit circle is cosine theta. So if we have a coordinate plane and we have our unit circle, for any angle that we draw in standard position, So where the terminal side of this angle, not the one that's on the positive x-axis, but the other side of the angle, meets the unit circle, the x-coordinate is cosine, the y-coordinate is sine.